Everyone again. So I will continue to central limit theorem. So central limit theorem essentially, as I said, it talks about the why normal distribution is so important. So this is the main question of the central limit theorem. Say that I will just continue from our previous slides, and this way also you will see how it makes sense to use the central theorem for the population and the sample. So we have a population of gears, and then we are trying to guess what is the, for this population, what is the average gear diameter, and then also we are looking for, so that average gear diameter plus minus there is some range of the diameters, yes, and this is also we are looking for the standard deviation, or you can say the uncertainty part of it or the spread of it. So this is related to standard deviation, but I'll just go to with uncertainty. Yes, we are looking for uncertainty or spread of our data. So to guess these values, I take sample 1, 2, 3, 4, and 5, and then up to sample m. So I take m number of samples, and for each sample I have some gears. So I measure diameter of this gear 1, I measure diameter of this gear, and then measure diameter of this gear, and then for sample 1, for example, so we have the n number of gears. So what it means is that we can have 10 gears for each sample, we can have the 15 gears, it depends. And also finally we have the m number of samples. This one is m. So you can have the 100 samples, you can have 50 samples. Again, it depends on the problem and on the case that you are trying to analyze. And then the next step is that similar things you do for this one. You measure the diameter, you measure diameter here, you do here, and then you do here, and for this gear. For all of these gears, you measure the diameter. Okay, and the next step is that you write the values that you have. For example, sample 1, this one is the gear 1. And then sample 1, this one is gear 2. Sample 1, this one is gear 3. And then we have the gear 4. We have gear 5. And then this one goes up to have the gear n. So as I told you, the n means the number of gears in each sample. Each sample. So we do for sample 2, 3, 4, 5, 6 up to sample m. So m means that the number of samples. How many samples do we have? It's determined by m. And then how many gears do we have for each sample? And then it is given by the n. Next step is that we take the average of each sample. So what it means is that I add this number 75, 74, 74, 75, and then divide by the number of them. So this is the average. You take the average of this one, you take the average of these numbers, you take the average of these numbers, and to say that this is sample 1, this is the average of sample 1, sample 2, the average of sample 2, sample 3, the average of sample 3, and then sample 4, we have the sample 5. So this way we are taking the average of each samples, and then finally we have the sample n. Okay, and then we just write them. So for sample 1, say that you got the average as 74, sample 2, 75. This way you do for all of your samples up to the sample n. So for each sample we have the the average. So 7, 7, 8, 9, we have 10. Okay, so this one should be 11. I missed a number here, 12, 13, 14, we have 15, 16. Let me just correct it. This one's 20, 21, 22, 23, 4, 5, and then 6. So for each sample we have the average of the diameter. So this one is average diameter. Okay. The next step is that we take the average of the average. This is also called the grand average. So what it means is that if I go back to here, so grand average, we show it as the x double bar. So that one will be called the x bar 1 plus the x bar 2 plus the x bar 3 plus the final x bar that we have, that is m, and then divided by the number of them, which is n. So in this case, if I go back to my example, it will be that 74 plus 75 plus 78 and then 71 and then 70, so up to the final one, which is 70, and then we divide by the n. This is the grand average. Okay, so we go to Excel and then we enter our data and then plot to see what's going on there. So let me just go back to Excel. Let me just check if it is recording. Okay, so if you go back to Excel here, so I did this one in a failed recording. So this one I will just erase this part as well. Okay, so I have the data as in this PowerPoint. So for example, 1 is 74, 2 is 75. These are the averages, and this one is the number of the sample. First sample average, second sample average. So in this problem I took 108 samples. So as you can notice, that is 108. So m is 108. This one is given. So n not given, but this is general example, so n not given, general problem. But it's not so important to have the number of n, since this one is a general example. But I can put a number for you to make things easier. Say that I am choosing the n as 49. Okay, to make things easier. So I have 49 gears in each sample. I have 108 samples. Let me just write it here. So we have 108 samples. So m means that 108, and then for each sample, so there are 49 gears. So we have the n as 49. Okay, but you can go with the lower values of n. Okay, so it's also okay, but this is just an example. Yeah, this is just a problem. So you can go with the any m value that you want and any n value that you want. Okay, this is just a small example to show you how it works. So, and then what I will do is that I will count what I have. How many numbers, how many times that 74 appears, how many times the 75 appears. So I will just do that here. Let's do that. So first thing is that before doing that, I will just find the minimum and then maximum numbers in my range. So it will be that minimum of the numbers here. This is the first step that you do. Then I will do the maximum, similar formula here. Just I will put the max here, and the range should be the same range. I can check the ranges from B2 to B100, B109. So just one B2 to B109. Okay, this is the maximum. So what it means is that I will look for numbers in the range of 70 to 80. Okay, and to count how many times that 70 appeared. Okay, so what I will do is that I'll just go and say that count if, and then I will count the 70 in this range. So let me just select the same range, and then for this range I will just use the criteria is that which number you are looking for. I'm looking for 7. It says that 1. So what it means is that in this range 70 appeared once. You just need to copy and paste the formula down, but here the thing is that I have to keep the range as constant, so I will just press F4 or $sign. Okay, so then I will move it to, you can see now the 71 appeared 3 times, 72 appears 7 times, 73 9 times. You can count yourself as well one by one, but it's a good amount of time. So then I count what I have, and then I will calculate the grand average. So to calculate the grand average, let me just add here. Grand average is just the average of the average. So I will just select the average of the average in this range. B2 to B109. I will not go that way, and I will just put it this way. You can see this is the grand average. So just put a rounded value here. And then I will plot it. So let's plot the numbers and the occurrences, how many times it appeared. As I said, you have two options, to scatter or any of them actually, but I generally start with the scatter because it gives me the X and Y data, so I can be sure that I selected the correct range. But you can directly start from the bar chart, central limit chart. So I will have the X values, and then I will have the Y values. Okay, so you see this one is the result of the central limit theorem, and then I change the chart type. You can do that one as well, or you can keep as it is. You can see this is how it looks like, but this is a surprise. Why it is a surprise? Now you will see that, because it is. So this one looks like a normal distribution. Okay, so the is what happened now. Let's summarize, and then you will see why the central limit theorem is so important. So I will just stop the recording here, and I will continue in the next recording.